Hello again. In this video, we're going to explore command line arguments in a Makefile. Now, we're only going to scratch the surface of the things that we can do with this today. So if you want more information, particularly about Makefile, I strongly suggest checking out the notes that I've put in the public folder, particularly with respect to Makefile. But to get started, let's look at the first exercise. So we're going to make a program that takes a molecule as a command line argument, like H2O, and outputs the number of atoms of each element in the molecule. So for instance, if I give it H-2-O-1, should say there's 2 hydrogen, 1 oxygen. So let's get this started. We are doing O4B, command line args and Makefile, and let's make our file. This will be example 1. Stream. Okay, so we're used to writing our main functions like this, no parameters, but it turns out there are 2 very common parameters to put in here. One is the count of how many arguments there are, the argument count, and the second is a character array. Basically, I guess it's not a character array, it's an array of, it's a string, really. It's an array of characters, which we'll call argv, and this is going to store whatever variables we pass to it. And because each of these is a single string, we may get many, many different arguments, so this is actually an array. You can also put this as a double pointer, that's fine as well, but this is probably the most common way to think of it because it's literally an array of strings, which is here represented by characters. We can't actually put string here simply because the way that we're reading things in from the command line doesn't exactly equate to a string, so we're forced to use this, which means we're going to have some limitations on what we're actually able to do with the text that we're reading in, so you have to be a little bit careful about that. Okay, now, we are reading in, presumably, a molecule. Now, this program is going to expect us to have that molecule, which means the argument count should be 2. One is the name of the executable, and the second is the actual molecule that's being put in here. If for some reason argc is not equal to 2, then they've clearly run this program wrong, and we need to explain to them to do something different. So we'll say usage dot slash executable molecule. And this basically means that they did it wrong. Otherwise, we can assume there's exactly 2 arguments, which means that the molecule we're looking for is going to be argv1. Now, in order to handle this, we probably want to be able to convert this to a string. I don't remember off the top of my head if toString will do it. I suppose I can check the C++ to see. So char array toString. What's the best way to do this? Sure, what's the suggestion here? We can use size of potentially. I'm not sure if that works. I don't think it does. I'm not very convinced. I bet you there's a function, and it's not coming to the top of my head. Use str to cast it. Let's see if that works. I'm going to make sure this actually is functional. So string molecule equals str argv1. argv1, because the first argument is the executable name, number, which is at index 0. Number 1 is the molecule that I want. Just make sure this works to see if I can output the molecule. Before I go any further, I want to make sure I'm doing things properly. So, oops, wrong button. Let's compile. Did not like that. Okay, so str, clearly not what I'm looking for. Can I cast this to a string? Let's see. How about like that? Looks like it allowed me to. Okay, this clearly can't do it that way. How about H2O? Or sorry, H2O. Okay, so we just had to take the argument and make it into a string, and now we have a string. And since we have a string, we can take advantage of all the nice string methods available to us, such as the length and so on. Okay, so if we've got our string with our molecule in it, now we want to output the number of atoms of each element in the molecule. And something to be mindful of is that not all elements are a single letter. For instance, magnesium is Mg. So I need to take account for the possibility that we have 2 letters or 1 letter potentially. So probably the way I want to do this is, so the first thing I'm going to do is I want to print out everything until I hit a dash. And then I want to print out a colon and a space. And then I print out the number. And then I hit the dash, and then so on and so forth. Now, I want to also be mindful that I want to be able to handle situations such as molecule counter. I guess I should, call out our executable. Molecule counter, Mg10 nitrogen 5 should output Mg10 nitrogen 5. So I have a little bit more work to do to figure this out, but I think I can manage it if we are mindful about the way that we iterate through this string. So we're going to do it, I think, character by character is probably the best way to do it, although there are other options for sure that you can consider. So let's do for I is 0, I is less than the length of my molecule. It's molecule.length. Plus. We're basically going until we're going to look at every character of our string to figure out what to do. Okay. Now, first of all, if it is a capital, so we got a couple of possibilities. So option 1, it is a capital letter. Then we want to print it for sure. And the next character, if that character is lowercase. So basically, if I see an N or I see an M followed by a lowercase g, then I want to definitely print out the letter that's the capital letter for sure. And then also, if the next letter is lowercase, I want to print it and also skip it. I don't need to print it out. So if, I believe is upper is valid for this. So is upper molecule index I. Then we'll print out molecule index I. And if is upper is lower molecule I plus 1, then I'll output that as well. And I will skip. Now, if I don't run into a capital letter, note that we're going to skip all lowercase letters for sure. Then one possibility is a hyphen. If there's a hyphen, I don't really want to do anything. But if there is a number, then I want to basically print all numbers after this and then skip past them all. And then proceed from there. So, else if, no, I think, again, off the top of my head, I don't remember exactly the function I want for this. I can do the ASCII math to figure out the exact values that contain the numbers, but I think I'm just going to take the little lazy approach and look up C++ is digit. It actually might just be is digit. Yeah, it is digit. Okay, so if is digit, and we're looking for molecule I. So this means that we have encountered a number. And then what we want to do is we want to output. So we're at the point where we've outputted, for instance, Mg. Now we need to output colon space and also molecule I. So now if we've run into Mg, we skip the hyphen, then we print out colon space 1. And then we say while And now we basically want to go through all the numbers that are there. I still needs to be less than molecule.length. I don't want to go over the length of the string. But also molecule I. Sorry, and then I'm going to go... I is less than the length, and molecule I... I think I might not want to use I here, just to be very careful about my indexing. So what I want to do is, potentially this could be a whole bunch of numbers, right? I want to basically make sure that I'm printing out every single number that's here, but in case this comes at the end, I don't want to go over the range. So how to do this? One option is I can make a new index, which is totally fine. I think that's what I'm going to do. So int j equals I plus 1. And then we'll say, well, j is less than the molecule length, and molecule j is a digit. Then what I want to do is output molecule j and go j++. So now I'll print out every single digit that shows up until I reach the end. And I think that's exactly all I need. Let's see if this works. Okay. Compile example 1. Run it. I should compile it to what was it, molecule counter. Do it properly. Okay. So molecule counter, and let's say H2O1. Okay. Small error here is we should have a comma before the O. So to fix that. Yeah, because we should have a comma here. So there's a couple different ways to do this. One is to sort of reorder it. The other is the slightly messier approach that I'm going to choose to take, which is basically to, because I don't want to have a comma at the end. That makes things look a little messy. What I'm going to do is I'm actually going to have a Boolean for whether it is so the idea is I want to basically, every time I run into an uppercase character, let's actually print out comma space before it, except for the very first one. So if it is the first element, so is first element equals true. So then if it is not the first element, then I want to output comma space. Otherwise is first element equals false. So a little messy, but basically what I'm doing here is I want to make sure for the first element I simply flip the switch. But for everything else, it should actually have a comma and a space before I print out the capital letter. And this should fix my mistake. There we go. Let's make sure again this works with something messier. It's like MG2O1000. Woof, we got something messy going on here. This looks like it prints out a whole bunch of extra stuff I shouldn't be printing out. Let's see if we can figure out why. So, printing out a lot of colons. It's not printing out any... so I think I know what's happening. Here, while I'm incrementing through J, I actually should be incrementing through I. So, what I actually want to do is add I++ here to make sure that I'm skipping through the numbers as well. So let's compile, try again, there we go. So the reason I messed this up is because by not incrementing I, I'm actually going to check the the 1, and then I'm handling the 1,000, which shows up here. And then I hit the 0, and I treat it the way I treat numbers, which is add a colon, put some zeros, and it all looks super messy. But by making sure that my I is moving along the string at the same time as J is, I print out everything as desired. So there we go. It took a little bit, but we've finally figured out how to parse our molecule regardless of how it looks. But that's just part 1. Let's move on to part 2. In part 2 here, what we're going to do is modify this program to support a -s flag. And -s, when used, will let somebody input a simple format. So NaCl4 instead of something hyphen something and so on. Now keep in mind here, we notice that Na is not followed by a number. So we still need to figure out that this actually represents a number, which means we're going to need to use a slightly different approach. For this, I'm going to copy my code because I still want it to work normally with the original version, but now I need it to work with the -s flag. So now there are 2 possibilities. I could either have 2 or 3 arguments. So now I need to basically say if argc is less than 2 or argc is greater than 3, because it needs to be either 2 or 3. 2 if it just has the molecule, but 3 if it has both. Now, for int I is 0, I is less than argc, I++, I'm basically looking at every argument in the vector. I can skip the first one because that's the name of the executable. If arg, so here I have to be very careful because I think that -s isn't exactly a string, so I might want to do the same kind of thing where I take string element equals string argvi, and if element is s, and let's make a Boolean called simple format, which will normally be false. And here we'll say simple format is true if we see that flag. So that way down here, I will go if not, so if simple format, otherwise do what we did before. And so all this will be the stuff we did before. But if we have a simple format, we'll need to do things slightly differently. Now, I believe that I need to do some stuff the same way regardless. For instance, I'm definitely going to want to know if it's the first element. I'm definitely going to want to figure out what a molecule is, which in this case, it's actually not necessarily going to be argv1. In fact, here my molecule is actually going to be at argv2. I think I still want the Boolean first element just in case. But now let's work how to do this if we have different formats. Now the format is going to look like a mix of capitals and lowercases. Sometimes there'll be a number, sometimes there won't. But as soon as I see a capital letter, I know I have reached the end, which means that there may potentially be only one element. So let's think about how to parse this out. First of all, I'm definitely always going to print out the first character. This is like without a doubt what's going to happen. So I'm always going to output what is it, molecule 0. No question. But do I want to do it this way? Not necessarily, because again, I kind of want to loop through the whole thing. So let's start with that perhaps. I is 0, I is less than the molecule length, I++. So now we're kind of parsing through here to figure out what to do. In order for this to work, what we kind of need to do is keep track of how we have been handling everything, because again, we kind of need to be able to handle what happens if there's multiple digits, what happens if there's no digit, and so on. So for this, what I think I want to do is I want to figure out if I have encountered a number. So let's think about the different scenarios. What are the letters that I could run to? So one possibility is uppercase. If I run into uppercase letter, that means that this is a new element. If it's the first element, then just print it. Otherwise, print actually, do I want to? Yeah. I don't want to just print it regardless, right? Otherwise, oh yeah, so there's a couple of different scenarios I can run into. If it's a first element, I just want to print it. Otherwise, if I run into a capital letter, I need to figure out, did I finish printing the run before? So, otherwise, if the previous character was not a number, print 1. Then print it. Because I need to handle like this scenario here, where there's sort of an implicit 1 hidden inside right here. It's not 1, I guess it's technically 1 comma space. But you know what I mean. Okay, so that's one possibility. This is uppercase. Lowercase, just print it. That's kind of easy. Digit, pretty much just print it, right? We run into, yeah, we're just going to print it. That seems fine to me. Let's see, and if this doesn't work perfectly, we'll figure out the corner cases and work on them. So, obviously, if it is uppercase, and we have the same code from before here, right? If is upper molecule I, then what do we do? Well, we probably want to have our is first element. So if is first element, then output molecule I. Otherwise, and now here's the tricky thing, is I had to check the previous character was a number. So here, I guess what I can do is I can say if, and so I know that if I'm not the first element, then I can do I minus 1, and that should tell me what I'm looking at here. So if I look at I minus 1, molecule I minus 1, and that is not a digit, so I get to this C, for instance. The previous thing is clearly not a digit. Then I should print out the 1. It's specifically 1. And we'll figure out the punctuation and stuff after, but I think I just for now want to get the symbols to show up properly. So if it was not a digit, then I'll print out that. And if it was a digit, then presumably it should already be handled. Okay, so I printed out if it's the first thing. Otherwise, I print out the 1, and then I print out the molecule letter. And then otherwise, I'm just going to print it. Let's see how this looks. I don't think this will work perfectly, and it's definitely not going to have the right punctuation, which we need to fix. But let's see how it looks for now. Compile exercise 2 into molecule counter. Compile's okay. Let's see if I pass it in a CL4. So it didn't give me the 1. That's a problem. It gave me a comma, which I don't remember putting in. Oh, yes. I know why that happened, because I forgot to give it the flag. So it only handles the simple ones if I give it -s. So this should be molecule counter -s in ACL4. Okay, and now once again, we have all the letters. It did not print out the 1 here that it should have. So that's a mistake I need to fix. Let's see why that is the case. So when we look at the C, the previous symbol should have had us print out a 1, but it didn't. And I think the reason for that is we never flipped is first element. So if it is first element, then I do this, and now is first element is now false. So I forgot to flip that sign, which is why I kept thinking that everything was the first element. Let's try this again. Compile, go. Okay, now I have all the right numbers. I just need to work on the punctuation now. So after I print out a, so before I print out a number, I should have a colon and a space. So if molecule I is a digit, now here's what to be very careful, because again, if I have 40, I don't want to print out a colon and space for every single one. So what I want is if it is a digit and the previous one is not a digit, is that all the right parentheses? I need one there. Then I want to print out colon space. And I think what I can do as well is after I print out the number, I can check to see, is it the very last number? If it's the last number, I won't print out a comma. Otherwise, actually, when should I print out the comma? I should print out the comma if the next letter is a uppercase letter. Otherwise, I should not. So I think that's the easiest way to do it. So if we printed out the number, then if it's a digit and the previous so if I printed out yeah, so I printed out the number, I'm at a number, and there should be a there can be numbers before it. There could also be letters before it. But there's definitely an uppercase letter after it. That's when I should have a comma. So, and is upper molecule I plus 1. Then I will print out the comma. Okay, let's try this out. Kind of piecing my thought process together, but I think I may, okay, not quite, because it gave me the one without the space, and that's because I need to format this properly. There should be colon space 1. Let's try that now. Almost there, it's just missing the comma that should be here. So when I print out the 1, because when I print out the 1, I don't actually see, yeah, so this should always have a comma. Yes. Get rid of some comments here. Okay, I think that should fix our current scenario. So now we print this out. I guess I'll add a space after the comma. There we go. Just fixing one little bit at a time. Okay, I finally figured out how to handle all of the spacing and everything. There's one last little trick, which is that right now it doesn't handle the reverse. So if I try to do Cl4Na, notice it forgets to do the 1 at the end. So the last thing I need to do is double check, is the last character of my molecule a number? So where is our loop? This is our loop. So finally, if molecule at index molecule dot length minus 1, the last thing is not a digit, then I need to output, I think it's just colon space 1. And I should put it in an end line. Let's see if that fixes our problem. So there we go. And I think now I can even put in more complicated things and it should still handle it. CO50, MG20, h6, and there it's parsing all of them perfectly fine. Okay, a little messy, but we finally managed to get things done. Now we can move on. So with part 3, we're going to do something a little different, which is now we're going to make a new program that has 2 simple classes, element and compound. Elements class will have the member's symbol and atomic number, and the compound class will have a vector of element objects. We'll write a Makefile for compiling these and a main function. So in a completely new folder, we'll call it exercise 3. Let's make ourselves a new file starting with element. Okay, so I need a class called element. If I'm going to have a symbol, which is going to be a string, I should include iostream and the standard namespace. So here we'll have a string symbol and an int atomic number. And I guess we'll make a constructor, we'll make an empty one, as well as one that will take int a and assign them. Symbol as atomic number a. Okay, everything's public for now, so we won't worry too much about that, but I do encourage you to figure out ways to make this a little better with private variables. Okay, so now I have my element class. Now let's make a compound. Compound.cpp. And here I'll have a class called compound. In order for this to work, it needs to include element.cpp. And here again, I will just have, and also I think I need to include vector because I want a vector of the elements. So I'm going to have a vector of elements called elements. And I suppose I should have a name for it too. Okay, so I have a compound, I have an element, and now I need to write a Makefile for compiling this plus a main function. So let's get our main function first. Now, this is probably not the ideal way to set everything up. That being said, the code for these two is so short, I don't think it's really necessary for me to make a whole header file or anything for them. But what I might do is I might, actually, can I? No, we'll keep everything kind of simple, and we will we'll just do them all separately. Okay, so my main function, let's include compound. And just to test everything out, let's make some elements. E equals element H1. 2 will be HE2. I think the third one is lithium. I could be wrong. And compound C equals compound. Did I give this a constructor? I did not, so I should do that. Compound, given a string n, assign it to the name. And here we'll just call this my compound. And C dot elements dot pushback E E2 E3, and I should be able to print them all out. For element E in C dot elements, output E dot name symbol, right? Okay, now just to make sure this all works, I want to compile it and run. Okay, but this is poor organization, and the reason is, even though these are small, and like, to be honest, there's not a lot of sense in splitting this up into headers and such, it is certainly possible that I may have the element classes do a little bit more. So perhaps instead of just accessing directly the symbol or directly using pushback. I want to put some methods into these classes. So let's say, for instance, I want to have a void display function. Now, I should split this up. I should have a header for element, a header for compound, and then the CPP file separately. So I think for element, I'm just going to do display. And I'll do the same thing for compound as well as an add. So void display. We'll also do add element given an element. Now I can actually make this a little nicer. I can make these properly private as they should be. Let's just put these up here. Similarly here I can make these private. And let's split these into headers and CPP files. So I'm going to start with element. So let's do element.h. So element.h will look, I think, exactly as such. And element.cpp is just going to implement our display function because everything else here is already written. So I can clear most of this. I just need to implement display, and I need to include element.h. Display from the element class will simply output this arrow symbol has atomic number, this arrow atomic number. Seems fine to me. And then for so that seems fine. And then for our compound, we'll split that up as well. .h. So the header will look basically just like this, and our CPP will not have any of these things. It will include compound.h. Get rid of all this. Is this correct? Yeah. And now we'll implement compounds class methods. For add element, this one's pretty easy. I can just say this arrow elements dot pushback e. And for display, we'll do what we were doing in the main function, which was for each element output the symbol. We'll make this display look nicer because our goal actually that we'll do in the next exercise, I believe, is we'll make this function do what the second exercise did, but we're not quite there yet. For now, I just want to print out all of the things. So here I just need to access the elements of this. And now I have everything split up into different files. So my CPP files have my actual functions, element and compound. The headers just describe what these things are. And my main now can simply include element.h and compound.h. Because I know I'm going to run into redeclaration issues, I should mark both of these as pragma once. I'll do that for my compound and for my element headers. And now, rather than doing all this, I should actually be able to do, what was the function I called? Add element. C.addElement, 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 and then C.display. Make my main function a little bit shorter. Okay, let's see if this works. Now, to compile this, I can't just do main.cpp, because if I do, it's not going to know how these compound methods function. In fact, also my compound here that displays each element, I should just use the display of the element. So I should actually be using e.display. Probably makes more sense. Now, in order for this to work, that means I'm going to need to compile three things: main.cpp, element.cpp, and compound.cpp. Multiple definition of element display. I defined it here. Did I define it here as well by accident? Multiple definition of display. Compound is there. I wonder why it's complaining about that. Okay, where does this error come from? In function display. Could be that I'm calling too many things display and that's leading to problems. Here is where I have it. This includes the element. This defines the function. This defines the compound version of it. If I comment this out, do I have the same problem? Multiple definition. I'm surprised why it says multiple definition of it. Are we including the wrong things? Ooh, here we go. This is the issue. I'm including the CPP file in my compound.h, but I should not. I should be including element.h. There it is. I knew something was wrong. Okay. There we go. So now I can compile everything, but you notice it's kind of slow. Like, look how long it takes just to compile 3 little files. So this is where the concept of Makefile comes in. I'm going to call this Makefile. And our Makefile is going to have some special formatting. So what I want to do is I want to set up my code so that when I make a change to just one of these things, it doesn't modify everything. So there's a few things I want to do. First of all, when I run make, I want to basically try to build my whole thing. And so effectively that means I want to build everything. And to build everything, I need to have main.o, element.o, and compound.o. And now, just a little settings, I have to set my indentation to use a tab, because if you just press the tab button, you can see it spaces over 4 spaces, but that's not actually useful in a Makefile. You need to indent with tab to see this little arrow show up. If I have these 3 object files, then I want to simply do g++ -o, and we'll call this, what is it, molecule builder counter, from these 3 files. I want to combine these 3 files together to make my molecule counter. Now, what happens if I don't have those files? Well, main.o requires me to have main.cpp, and if I do, then I need to do g++ -c main.cpp. I need this exact same thing for all 3 of my other files. So element, 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 compound, compound, compound. And now what this will do is allow me to go over here and just type make. And so make has compiled main.cpp into an object file, element.cpp into an object file, compound.cpp into an object file, and linked them all together to make my molecule counter. The molecule counter I have here is not really doing anything because my main function, yeah, let's make it display. So it actually does something here. Make, print out my 3 little things. But here's the neat little trick, is now, let's suppose I change something. Let's suppose I make it so that this has the word "and" instead of atomic number. If I wanted to, I could either go back to where I had everything before, where I compiled everything from scratch, or I could just type make. And what make will do is it will see that I only changed element.cpp. So it only needs to rebuild element.cpp. It doesn't need to rebuild all the other files. And this linking process is way quicker than recompiling everything with g++ main.cpp, element.cpp, compound.cpp. Like, look how slow that is. Whereas make, boop, the linking is basically instantaneous. And so setting up these make files, while the process of setting up the make file obviously took some time, it saves us in the long run because these compile times can add up quite a bit over time. Okay, so is there anything else for this exercise? No, I did what I needed to. Now we'll wrap up with the last one. So our final exercise here asks us to modify our code from exercise 2 to use our new classes, and then modify our Makefile to use some variables instead of being entirely hard-coded. And we'll also put in a phony target clean that will remove all the objects and targets files. I don't know why I have the word then there. Yeah, I think that's fine with me. Was there something else I wanted to do here? I feel like there was something. I'm trying to remember what. No, I think that's okay. All right, so let's get started by copying everything from here, oops, into a new folder, exercise 4. Okay. Now, we still want to be able to do this process here. We want to basically have what's going on from this file from exercise 2 in our main for exercise 4. But there's a catch, right? Which is that we don't want to have all this code that handles printing out the stuff from the molecule inside our main function. This is just not good design. Really, all of this stuff has to do with putting together our molecule, our compound, which means that almost all this code should actually be part of our molecule, or of our compound class. Now, our main function should do some of this stuff. It should figure out what our command line arguments are, should determine if we're doing things simply, but everything basically from this point onward over here should actually be part of our compound class. Now, that means that we're going to need to have some new methods for our compounds. We want to have a, let me temporarily turn off the tabbing thing. We want to have void display, and I guess what we'll do is we'll give this a Boolean called simple, and then if it's simple, we'll do one thing, otherwise we'll do the other thing. And so here, bool simple, and now here is where I'm going to put in the logic for working out my compound. Actually, maybe there's an easier way to do it. Now that I think about it, I've written all this code already. Rather than reinventing the wheel, what if I just build some elements out of the string? There's, I guess, a number of different ways I can approach this, but I think what rings best to me is actually to use some of the code that we've done here and see if we can build everything into our classes that we've written. So the fact that we now have elements and we have a compound that contains vectors, basically what I think I want to do is I want to take the string that they've given us, figure out how to create the elements out of it, and put them into these two classes that are here. Now what's the easiest way to do this? I think I may want to scrap most of this because this works really nicely for printing, but it's less useful for actually organically working with our classes. So I think basically instead of modifying our code from exercise 2, we'll say this reattempt exercise 2 using your new classes. Yeah. So this whole process here, I think we want to just trying to think if there's some way that we could kind of integrate this into the classes. I don't think there's a really easy way, though. The way that we've written this code in particular is one that's like really quite messy and kind of ugly in a way. Now, I suppose instead of just the more I think on it, the more I think this is actually just not an ideal way to solve the problem. What I want to do is I want to take the string, I want to go through it and build out all of the elements, and then once I've figured out the elements, I want to put them all in a compound and then call that compound's display method. And so the display method of the compound will handle all the punctuation, and then all I have to do is figure out how many elements are there in the molecule. So for that, what I think I will do is I'm going to basically eliminate most of this. Or maybe I don't have to. Let's see. So I do definitely want to know what the first element is. Okay. So what if, instead of printing things out, I store them as strings and then use them to build elements and then put them into my compound? So I think we can maybe make something out of this. So let's say compound my compound equals compound, because I have to use the constructor with a name, but I don't need to give it a name, that's fine. Now what I want to do is, and I don't think I'll use this display function that's Boolean actually. I think I'm just going to have it always display the same way, but we'll need to parse the string in two different ways depending on whether or not it was simple. So our main function here is mostly going to handle the interpretation of the arguments, and then we'll use our compound and element classes to actually store the data that we're reading in. So I do want to keep most of this here, because instead of outputting things to text, I'm going to try to build some elements. So string element name is going to start out as empty. And then for whenever I print out, so here I'm printing out the text of a molecule. Let's, so the more I think on this, the more messy I think it's going to get, to be honest. Because what I'm going to have to do is I have to figure out still what the names of my molecules are. I guess instead of, yeah, okay, no, we can rework the logic. Element name plus equals this molecule. So this is where I'm putting in the first capital letter. So that's what I want to do here. What's this scenario? This is a scenario where I have gotten to a capital letter and the previous so the previous character was not a digit, which means I'm in a scenario where it's like NaCl. And then I hit the C, and that means that sodium only should have 1. And so actually what I'm doing here is not that I want to print out 1, but instead that I want to send this new element that I built, element name, into my compound. So, yeah, so in that case, I want to make a new element, E equals element name, and then my compound dot add element E. Basically, I've run into exactly 1, so I should just add 1. Otherwise, so what's this scenario? This scenario is I have, hold up. So this is it is an uppercase letter. And now this is putting the new element onto the screen. So this is, if I was doing NaCl, this print here is printing out the C. So what I want to do then is I want to say element name is this plus molecule I. So here I'm resetting the element name to be something new, plus a new capital letter. Otherwise, so we got a few different scenarios to consider here. This is again a little bit of a messy way to work through it. And I think I may want to scrap this in a sense, but we got, again, kind of the parts that we're looking for here. If what I'm looking at is a number, and the previous one is not a number, that means I have figured out how many there are. Maybe, not exactly. So because I was doing this character by character, this means I basically hit the scenario where I've got something like MG2SO whatever. And that 2 means I now am going to print out the colon and then the number that's there. So if I'm in this scenario, what I actually want to do is, then what's this scenario? This is a scenario of basically just moving on. I think I can kind of scrap that. The comma is not that important. I don't really need to know that there's a comma here. So if I'm looking at a number, and the previous one is not a number, and the other possibility that I have is that it is a number This gets quite messy, doesn't it? We have a few different options. We're looking at a number with a number before it. We have the option of we're looking at a number with a character before it, or we have the option of we're not looking at a number at all. Let's start with we're not looking at a number at all. That's actually the easiest one. So if not is digit molecule I, that means we actually should just are looking at basically a lowercase letter, I think is our only possibility. So we can just say plus equals molecule I. That makes it kind of simple. Now otherwise, now here's where it gets quite nasty actually. Because we're in this scenario where if we start hitting a whole series of digits, we may have to figure out what to do there. I'm not sure there's a very easy way to parse this. I suppose what we can do is we can build a string that will represent the number that we're going to be doing and then convert that string to an integer. It's a bit messy, but I think this may be what we have to do. Now, if we've hit a... Yeah, okay. Ugh. This whole thing is getting quite messy, to be honest. And I'm wondering if I'm overcomplicating this question. You know what? I think what I might do is I might take a little shortcut here and say, for this, we're going to set a restriction. No more than 9 elements per atom. Or sorry, no, that's not right. 9 elements, 9 of one element. And this will be helpful just because I think it's actually going to get really, really complicated trying to figure out how to do the double digit stuff. And I encourage you to explore how to do it. It can be done. Just I'm realizing it's going to take a lot more coding than I would have liked to do in this video. So just to shorten this and to kind of get us more to the point, let's assume for a second that we're never dealing with double digit numbers or anything bigger than a 9. So in that case, if what we're looking at is not a digit, then great, we just add it. Otherwise, if what we're looking at is a digit, then we can say, so molecule I, so int num, okay. If it's not a digit, that means a lowercase letter, so we should add it to our element name. Otherwise, if it is a digit, that means that we have now an element name. We have simply to add that many elements to our compound. So for I is 0, I less than string to int molecule whoops, did not mean to press that, I plus plus, element E equals element name, my compound dot add E. And we'll add that however many times are necessary, and then when we're done, element name equals null. Okay, we're not going to print, so that when we're done, oh yeah, so the last thing is, if the last symbol is just a letter, then we need to simply add one element. Okay, if I did all this correctly, then what I should be able to do now is call a display method from our compound. So my compound dot display, and we should see everything show up. And we'll write the display function. So our display function here is for each element display it. I guess that's fine. Now the element constructor requires an atomic number as well. I think we'll just say for now we're going to ignore the atomic number just to simplify this a little bit. Okay, and let's try making this. Okay, what I miss? I missed a parenthesis in the main in line 41 and also in line 52 perhaps. Definitely one here. 51. Is there a brace missing somewhere? There might be. So this brace goes here. This... Oh, an extra brace, perhaps. Okay. I don't know if there's an extra brace, but I guess we'll see. Hey. More extra brace. Okay, so there's definitely something missing here. Oh, I think that might be what it is I missed another parenthesis here, which then meant that this brace should be here. This one goes here, this one goes here, this is for else, this is for my for loop. Okay, there we go. Hopefully that fixed it. Ooh, what do we got now? Okay, so it doesn't like me converting molecule I, which is, I guess, a character. So the conversion of this to an integer it was not happy with. Perhaps there's another way to do this. So molecule I think is a character. It may not be a string. So string to int may be the wrong function. Let's see if I can take this and subtract 0. Since if it's a number, then subtracting 0 will actually give me the digit value. Okay, it seems to have built. Now if I do molecule counter dash s NaCl4, ooh, we got not quite working how we want. So what's our problem? Na has an atomic number, and then we did put in the atomic number, so this part's not going to work obviously, but it does look like it has put in 4 of the atom, or of the element. It just did not give it the right name. It called it number L instead of what it should be. So I think that has to do with the way that we're handling these element names. Yeah, so it got to here, and the element name was definitely wrong. Because what it should have done is, and it did the first one correctly, is Na has an atomic number, there's only one of them, and then we have somehow a space got put in there. Let me see here. So it added this one. Wait, so I've added the element. What is this doing here? So this is if it's a capital letter, then okay, cool. If it's not the first element, that means that if the previous one is a digit, I should add what's there, because that's my Na. And now my new element name should be nothing plus the current capital letter. And for capital letter, so I don't know why I'm getting space number L. Something unusual is happening here. Let's see what's happening to our element name every iteration of this loop. Na number. Where is number coming from? Something very unusual is happening here. So this is my loop. I get the first one, that's Na. Then I convert to a single element if the previous one is not a digit, because that means I have like NaCl4. So this added this one correctly. And here, element name becomes nothing plus the new capital letter, because we know it's an uppercase. So it should be a C, but somehow it's not. And it's instead number. What if I do like H2SO4? Wow, we're getting some really weird stuff is showing up in here. I feel like it's not correctly parsing through my string properly. H2, but it put it in 4 times. So there's definitely something really wrong with this. I think my logic somewhere here is not quite right. I bet something here is not doing what I think it's doing, and that's what I'm concerned about. What happened with this one? This one, it put in S exactly once. It put in H twice as many times as it should have, and it put in SO4, or it put in the O the right number of times, but it has the wrong names for these things. It called it... Where are these coming from? How is it accessing this data? So string molecule is string argv. Let me output molecule. I want to see what this looks like. Make go. Yeah, so it has this okay. It goes to the end of the molecule length. I wonder if this is causing some weird stuff to happen, potentially. Either both of these things may be doing not what I think it's doing. Let me see. Let's put some prints around here and see what happens. Okay, that's not actually helpful. 1. Two. Try that again. Burr. The H is being added the wrong number of times. And that's because, so it's not a digit, and I should just be adding to the element name, which makes sense. And if it is a digit, then that means for this many times I should add that many elements. Really solving the puzzle here. I feel like this is much more complicated than I had intended it to be, but perhaps it's good to see some problem solving. 3, 2. But then how did it get added 4 times? That doesn't make any sense. And then here the element name is not even getting set up properly. Why might this be doing what it's doing? So the issues are, in addition to, so ignoring the atomic number issue, which we're not really caring about, the names are not being built properly at all. So something is wrong with element name. This is clearly not being set to the proper value. it works fine for H, but then H gets added too many times, which doesn't make any sense. So when we try to add the element, it adds it in too many times, and add element is just a pushback, so that shouldn't be happening. Display similarly is for each element, it just displays it. And this is where something weird is happening for sure, because what we see is that between 1 and 2, we should have a change of the element name. But 1 and 2 the first time print literally nothing. Does that make sense? The first time we go through, we're looking at our first element. So element name should at least have H in it. Does this change anything? No. Well, so the order would be, let's see. So for H2SO4, what happens? We get the H, okay. The next thing that happens is we hit a 2. It is a digit. So I is 0, I less than presumably 2, I plus plus. Element E is element H, because we put in an H. My compound add, okay, that makes sense. And then the element name should be reset, because I've added 2 hydrogens. Okay. Now the next thing I should see is, okay. Yeah, okay, so it should be blank. Then the element name should become nothing plus what, S, right? Since we have H2S. But this is not working. Something is wrong here. Do I have to convert this to a string? We did not like that at all. But I think this is part of our problem, is that it does not, okay, what if I just do this, string molecule I? It's still very angry. Same problem, I guess. Yeah, it does not like me doing this conversion. So I think I've detected the issue. The issue is basically, I can do substring. I can say, because molecule is a string, so I can say element name equals molecule dot substring starting from index I going 1 character. How about that? Ooh, better. We still have a problem. So we've now successfully put in the symbols here, but H is still being put in too many times. Why? So this loop is being run the wrong number of times, I believe. Just trying to count. So this goes 1, 2, 3. Oh, it immediately goes 4 times. Right away. I wonder if this math is wrong? If something is problematic here? But it does 4 times properly for the other one. What if I do something else? What if I don't do H2SO4? What if I do H6SO4? So it's doing 4 times no matter what. H6SO6. Okay, now it's just being completely different numbers. 5 and 5. Okay. Clearly this formula is like causing it to do things in a very weird way. So we've got a digit here. Can I do int count equals this? Will that make a difference? Oops. Okay, what did I miss? Something simple here. Miss a semicolon. Try again. Make. Go. H6SO4. Was that it? It's literally just an issue with the conversion. H2SO2, yeah, H3SO. Okay, suddenly it's working now. So I guess probably the issue was trying to put this into the oh, I know what it is. I was writing this, but this is not started in parentheses, so it was actually comparing these two and then subtracting, and that led to some weird stuff. So here we go. Okay. This video has gone way beyond the time that I wanted it to because of working on these bugs, so I apologize for that. And I think that I may just have to leave the second half of this as an exercise for the reader. But the important thing I want to do, I didn't get a chance to do, is to fix this Makefile actually, because this Makefile is not actually ideal. Look at all these hard-coded things. So we can actually optimize this a little bit by declaring what are our sources, which are main.cpp, element.cpp, and compound.cpp. And our object files are, and this is where it's helpful also, by the way, as just a reminder to reference the notes here. One of the most useful things actually is near the bottom is a very well organized and structured Makefile that you can actually use for most of your programs. And so here what I want is this part here. For each source, replacing the CPP with a .o gives us the list of our object files. So here are our object files. Now, some other things we'll use from this. So first of all, when I want to compile this, I want to make all my executables. Now here I only have one executable, and it's just called molecule counter, but I think that's fine. So we'll call that executable is molecule counter. And here, all means to build, I think I want to just, yeah, all means to build molecule counter. And molecule counter means to take all my objects and build them all. So here is $executable. And I think I can actually put that there too. Yeah, executable. Just replacing everything with variables to make it a little more organized. And now here, for all my objects, basically what I'm looking for is I want each of these down here, and this molecule counter to be, this thing here. And so there's some special variables we can use for this. Here what we're looking for is where is it? So $$ at means basically the thing that's on the right here. Sorry, is it on the right? No, on the left. So for instance, this code down below, we're trying to build each object file. We use $-c $less than. $sign less than means the thing on the right. So if I'm not mistaken, what I should be able to do is the following. Is $sign at -o into $sign right. And for all of these, I can replace them with a single command, which is for any object file, given its CPP file, compile the, I believe it's the, the left-hand side? That should work. Let me double check. Make. Okay. Oop, what did I not do? Means I need my executable. Oh, I think I messed up the Is this what I'm looking for? 1 second. I want to combine all my object files to make my executable. But I think I want to do this, right? Let me see here. Main.o. Linking not done. Okay, so it's not linking it together. And that's because I think I wrote this slightly wrong. So my executables needs to take my objects and so like this. And then to build my CPP files, I combine, oh yeah, so here's I think my problem is I want to take each of these and combine them into my objects. Is that better? No, it's still unhappy. Oh, I have these flipped, that's why. It's, is that right? Yeah. This to here. A little frazzled from all this stuff messing up. Can't find molecule counter.o, and that's because that shouldn't be there. To build. Is this what I'm looking for? Okay, almost there. Compound add elements and stuff are not included. And that sounds like building my molecule counter from main. Let's see here. What am I missing? So for each of my executables, I need my objects. Is this the right format? I'm like second guessing my own code. Make. Yeah, no, this isn't right because I don't want to be compiling molecule counter.o. So I think this may actually be wrong too. Well, I guess for this one, I'm building an executable the same name as the source file, so that's why this is actually doing what it's doing, but that's not what I want my program over here to do. What I want my program here to do is I'm going to take all of my objects and link them together to build my executable. So compile the things on there to build this. And now the problem is, well, no, that's not right either, because I need to have all of them. I think the problem has to do with this. This to build my executable actually depends on all my objects. Ugh. I feel like I blundered something here. This is right. Now for my executable molecule counter, I need all my objects, and once I have all my objects, I can take all of them and compile into this. So why is it building just main.o? It should have all of them, yeah? Oh, what if I do, instead of this, I do objects. There we go. Such a silly brain thing. Okay, because what I want to do is I want to take all my objects, I want to build all of them, link together to make my executable molecule counter, which now hopefully should run molecule counter H6SO9. Okay, and then molecule counter -s will give me the 6, 1, and 9. Okay, ooh, that was That was not feeling my best today, so apologies for the extremely long video that should not have been this long. But maybe you learned something from watching me struggle through working with this. I've been a little under the weather lately, so apologies for having a number of brain farts. But let's just talk a bit about this Makefile. So all the sources here are CPP files that contain all of our code. Our object files are all the sources, but with a .o instead of a .cpp at the end. And our executable is our molecule counter. When we run make, it will build our executable, which requires all of our object files. And anytime that we need an object file, which is a thing with a .o, we need its corresponding CPP file. This code here will compile the right thing, the .cpp, into the left thing, the object file. Once we have all of our objects, we compile all of them, not just main.o, into our executable. And now, again, the lovely thing about this is that now, anytime that we that we modify some part of our code, it's only going to rebuild as little as possible. If I just run make, nothing will need to be done because it's actually as up to date as possible. I'll make some very small change here. Let's say I just modify this so that, let's say I just add a comment, hi. Now when I run make, you can see it only had to change compound because that was the only part of my program that got modified, and then it quickly linked everything together. And this is a lot quicker than compiling every single thing all at once. So hopefully, despite my struggles and spending way too much time debugging, you got something useful out of this video, and I look forward to seeing you in class. Take care.